In this video, we're going to take a look at topic 5.2, the do you know how, numbers 5 through 7, which correlate with example 1 and example 2 in your text and your notes. So here we go. Number 5, 49 raised to the 3/4 times 49 raised to the negative 1/4. So notice right away, your bases are the same. They're both 49. You also are using multiplication. So when you multiply, you have same base, you add the exponents. So we have 49, you keep the base, take the exponents and add them. 3/4 plus a negative 1/4. Well, that's just going to be the same as minus 1/4. If you add a negative number, it's the same as subtracting it. Now notice in this problem, you already have a common denominator. So we are just going to simplify this. 49, 3 minus 1 is 2. 49 to the 2/4. I started to reduce it automatically. And I can reduce 2/4. Let me clean this up. So we can reduce 2/4 down to 1/2. So we have 49 raised to the 1/2 power. And as you might recall, anytime you're raising a number to the 1/2 power, you're taking the square root of it. So this is the same as 49, square root of 49. Index is 2. If you have an index of 2, we don't show it in the radical. We just understand if you see a radical, that means it's a square root. So the square root of 49 is 7. Let's take a look at number 6. We have a squared times b to the 8 divided by a raised to the 1/3 power, and all of this is being raised to the 3/4 power. First, we need to remember PEMDAS, our order of operations. You're going to do what is in parentheses first. So if I just ignore this exponent of 3/4 and I look inside my parentheses, I want to simplify whatever I can. Now I see I have a same base, a. And this is your quotient rule. So if you are dividing same base, you subtract the exponents. So let's rewrite this. We're going to, again, same base, keep the base, a raised to the 2 minus 1/3 power times b to the 8th, and then everything is being raised to the 3/4 power. So now I have to work with fractions. I need to subtract. I do not have a common denominator. So understand, if you don't see a number, a whole number, or an integer, you can convert it to a fraction just by putting a 1 in the denominator. I need a common denominator, so that would be 3. So what I need to do to 2/1 is just multiply the numerator and the denominator by 3. And when we do that, I'm just going to put it above. That's going to make this 6/2, or excuse me, 6/3. 6/3. And again, think about it this way too. 6 divided by 3 is 2. They are equivalent. So now that I have a common denominator, take your base. 6 minus 1 is 5. So I have 5/3 times b to the 8th. And then everything is being raised to the 3/4 power. And I'm running out of room. I'm going to start going down. Okay, so what's in my parentheses is now simplified. So I go to the E in PEMDAS, which is exponents. Here we go. We have an exponent of 3/4. Power of a power property. Make sure we also have a product here. You're going to distribute that exponent to both the base of A and the base of B. And when we raise a power to a power, we multiply our exponents. So here I have A raised to the 5/3 times 3/4 times b raised to the 8th power times 3/4. And now we're just going to be doing some multiplication with our fractions. I have my base of a. So you can look at this a few different ways. You could multiply across the numerator 15 and then cross the denominator 15/12s and reduce it down from there. I think it's just easier to cross reduce. You have these 3's on the diagonal. When you're multiplying, they just reduce out. 3/3 is 1. We can take that out. And what is left is 5/4. Now let's work with b. And now here I can cross reduce. Again, you could take 8 times 3 is 24, divided by 4 is 6. You could also cross reduce here. 8 is divisible by 4, so that would go away, and this 8 would become a 2. 2 times 3 is 6. Same answer. Okay, so now let's rewrite this. Now, this is going to go underneath a radical because I have an exponent that is a fraction. My b to the 6th, I have an integer exponent, so that stays inside of the radical. So my base is a, my index is 4, and then it's being raised to the 5th power. Well, I can reduce this even more because if I have a to the 5th, I have a set of a to the 4th in here that I can reduce out. So let's take a look at this another way. B to the 6th, I can write a to the 4, or excuse me, a to the 5th as a to the 1st raised to the 4th power. So there's a to the 4th, but I need a to the 5th. Well, if I just multiply it by one more a, that is now a to the 5th. And because I have this exponent of 4 here, my index will cancel it out. So this a to the 1st power can leave the radical. So my final answer is a times b to the 6th times the 4th root of a. And now let's take a look at 7. We need the 4th root of 1024 x to the 9th y 12th, to the 12th power. Okay, so let's break this down. (1024). That is 4 to the 5th power. And I know some of these because I've worked with them a lot, so they stay in my head. You can always grab a calculator. You could take the 4th root of 1024. Just be sure that you know how to use your calculator, because if you do put the numbers in incorrectly, you can get a wrong answer. Or you can just play around, take some bases and try raising them to different powers until you find one that gets you 1024. So 1024 can be rewritten as 4 to the 5th power. I'm just going to go ahead, and again, I'm going to do this in step-by-step detail. I'm just going to bring this down. A to the x to the 9th, y to the 12th. Okay, so now let's start breaking it down. Let's see if I can get any exponents of 4. So my index and exponents will cancel each other out. If I have 4 to the 5th, that is the same as 4 to the 1st power raised to the 4th power times, I need one more. So I've got 4 times 4 times 4 here, times 4 gets me 5/4. X to the 9th. let's think about it. How many sets of 4 can I get out of 9? Well, 4 can go into 9 2 times. 4 times 2 is 8. And again, there is x to the 8th power. Well, I need 9. So I'm just missing 1. So there it is. Now y to the 12th. 12 divided by 4 is 3. That one's going to come out nice and easy. So y to the 12th is also y to the 3rd raised to the 4th. And now wherever I have these exponents of 4, that index cancels them out. And what is left in my parentheses, oops, why did I do that? I didn't mean to do that. Ignore that. This is an oops. These can come out. So I have 4x squared y to the 3rd, index of 4. And what is left? I have this 4 here that I accidentally highlighted, my bad, and I have an x here. So my answer is 4x squared times y to the 3rd times the 4th root of 4x.